Okay, so before I start going over some of the problems that you guys had sent to me, I just wanted to put a list here of everything that was in this chapter. So the first thing we did was the extrema and also on an interval. So you're looking at local and also absolute maxes and mins. Rolle's theorem and the mean value theorem we covered next. So make sure you know those and know what to do for each of those. Increasing and decreasing, concavity, points of inflection, and then again, like I said, you will have one problem with the curve sketching where you have that list of everything, like domain, vertical, horizontal asymptotes. Where is it concave up, concave down, increasing, decreasing, um, everything that we did there. So make sure you go over that and know all of those different parts and basically everything that's above this is in there. And then finally, we ended the chapter with optimization. So, um, again, I'm pretty sure that's everything that we did in that test. So just make sure that you understand each of those. And if you don't, send me an email and let me know before your test tomorrow. Okay, so let's start going over this. This is number 6. This was from the worksheet that was assigned to you on November 9th. It was the 3-7, I think it was like last Monday or Tuesday or something like that I gave you this one. Here's a scenario for you. Let's say you get a call from Valvoline. They want to bring back the cylinder-shaped oil cans, and the CEO wants you to design an oil can that will hold 1 quart of oil. And you want to know and use the least amount of material. So you want to know what the dimensions of the oil can are. Now, I gave you some information here, and this is the kind of information that you are typically given. 1 quart is 57.75 cubic inches, and then also the volume formula. Now, since you're using the least amount of material, you want to know the dimensions of the oil can to use your least amount of material that they're saying right here is what you're looking for. We're going to have to use surface area. Now, for some formulas, or some shapes, I should say, some formulas are given to you. But I don't know that this is one specifically that you will be given, so it's a good idea to just understand exactly what you are being asked. So here's, pretend it looks better than this. There's a cylinder. So if we're finding the surface area of this, we need the area of the top and the bottom. Well, that's just a circle, right? So we can find the area of a circle and then multiply by 2 for the top and bottom. So the top, now we're going to multiply it by 2. So the top and bottom are the same. So the formula for area of a circle is pi r squared. And then we're going to add to that basically this, the piece that covers that basically connects your top and bottom, right? So let's give that a variable of height, and we have our radius right here. So to find the area of this piece, if we stretch that out, that's just going to be a rectangle that has a height, and then this distance right here is the circumference of the circle. So that's just going to be 2 pi r, and then we'll multiply that by h to get our, just length times width for the area of a rectangle. So let's come back over here, fill that in. We have 2 pi r times h. Now, this is your primary equation, okay? This is the equation that's going to help us to answer the question. So we need our secondary equation, and I'm actually, let me move this down here. I want to be able to fit everything. Let's try that again. I want to be able to fit this all in one screen here before we start to do the actual problem here. Okay, so now we're ready. So the secondary equation is what we will have to use to make this have one variable. Okay, so I'm going to solve for h because I already have a couple of r's in there, so that'll give me the least amount of work. So I'm going to use this volume formula, but I already know the volume of this can has to be 57.75 cubic inches. So I'm going to say 57.75 has to equal pi r squared h. So what I'm going to do is I'm just going to solve this for h. So I only have one thing to plug it in for here. You could solve for r and r squared and then, plug them in here, but that's just more work and we don't want to do that. So 57.75 divided by pi r squared. Now, we are going to use this to plug in here, but we will also use it later because this will give us our radius. And we're going to take that and plug it in there to get our height. So we will use this formula later on in the problem. Okay, so this is what we're starting with. Again, I need to replace h with 57.75 divided by pi r squared. Now, we can cancel some stuff out here, so I'm going to cancel out the pi's, and I'm going to cancel out this radius with one of these. So let's just clean that up a little bit more before we do our derivative. 2 pi r squared plus 2 times 57.75 is 115.5. 115.5 divided by the radius. Okay, so this is what we will now use. We're going to take the derivative of this, set it equal to 0 to get us our radius. Okay, so let me give myself a little bit of space here. So there, that's what I wanted to make sure I could have everything on one page right there. Okay, so let's go ahead and take our derivative and set it equal to 0. So SA prime, the derivative of 2 pi r squared, this is going to be with respect to r, so 4 pi r. Now the derivative of this, if you want to bring the r up and make it r to the negative first, doesn't really matter. Hopefully you've done enough of these so that you can kind of see the pattern that's happening there. But like I said, it doesn't really matter. You can move the r up, like I said, and make this 115.5 r to the negative 1. Move the exponent out front. That's why it's now a minus. Subtract it by 1 is r to the negative 2. That's where the r squared comes from. Okay, so either one of those will get you to this point eventually. Okay, set it equal to 0. 4 pi r minus 115.5 over r squared equals 0. We want to know where is the derivative equal to 0. That'll get us our max or min. In this case, we're looking for a min because we want to use the least amount of material. So let's see what we get here. So let's move 4 pi r equals, I'm going to add that over 115.5 over r squared. Multiply by r squared, so 4 pi r cubed equals 115. I know some of you could probably do this in fewer steps, but I'm just going to write them all out here. R cubed, let's divide that over 115.5 divided by 4 pi. And then this you can enter in your calculator. You know, you do your cube root here, do the cube root here, which on your calculator, there is not like a cube root button. You have a square root button, but your cube root button, basically, the way you're going to enter this is 115.5 divided by, I would put the 4 pi in parentheses like that, and then you're going to raise that to the 1/3 power. So anyway, whatever we do there, you guys probably know that already, but just want to show that to you. Approximate this to 3 decimal places, 2.095 inches. Now it would be the plus or minus, but we can't have a negative radius because we're dealing with real numbers here in real space. So it's a real can, so you can't have a negative radius there. So your radius is a positive. I'm sorry, you would not have a plus or minus here because it's not a square root, it's a cube root. Let me back up for a second. This is not, the only way you would get a negative here is if this were a negative. I'm sorry. So it's only the positive, 2.095 inches. So that is your radius. Come back up here to our formula for height. And let me erase this actually. I'm going to get rid of this right here so I can make it all fit here. And I'm just going to plug that in. So my height will be 57.75, all that divided by pi times the radius, which if you have that in your calculator, I would just leave the exact number in there, or you can do it like this. It doesn't really matter. If you use this instead of I used the exact number when I did my approximation, so my number may be a little bit off of yours, but I think maybe to 3 decimal places it might still be the same. I don't really know. Like I said, I just left the number in there, and I got 4.189 inches for the height. So those are the dimensions you were looking for. The radius was approximately 2.095 inches, and the height was 4.189 inches. Okay? So there you go. There's number 6 from the 11.9 worksheet. So moving right along, I gave you this worksheet. I believe this was on the 11th. And basically what we're looking for here is a very similar problem. We're looking for surface area because we're asked what dimensions should they use to create an acceptable aquarium with the least amount of glass. So that's asking about the surface area of this aquarium. So again, we're looking at, I'm not going to try and draw a rectangular prism without a top because it's not going to look like that. So you can pick, well, I will. It's not going to look that great, but can check and see if we have any 3D shapes in here, but I don't think we do. I think they're all two-dimensional. So let me see what I can do here. So first of all, we know that the base is a square. Okay, we're given that information, which is a very important piece of information. It does say in here a box shape with a square bottom. So that is kind of an important piece of information. And then we have the tops, or I'm sorry, the sides that will look like this. Something like that. There we go. That's about as best as it's going to get from me. I kind of overlapped those two right there. I should have made it a little taller. So anyway, like I said, you know, normally with a rectangle, we'd say length times width, but we don't need to say length times width because this is a square, so they're both the same. Typically, you would say like the side squared. I'm just not using the variable s because it's going to end up looking like a 5, and I already have 500 there, so I'm not going to do that. And then the height of this box, we'll just stick to h. So for my volume, normally for this we'd have length times width times height, but in this case, if I can get this to work, in this case we're just going to do length times height, right? Because the length and the width are the same since the base is a square. And again, like I said, that is a very important piece of information. Otherwise, we would have a bunch of variables, and then it gets a lot more difficult and confusing to you know, plug this into our primary equation. So this is our secondary equation. This does not help us answer the question because the question is asking about surface area, but we will need this later on. We know the volume is 500, L squared times H. So let me come over here and start working with our surface area formula now. And again, this is a formula that you would be expected to either know or come up with. So typically for a rectangular prism, we would have 2 times the base and the top, like the top and bottom would be the same. But this is open top, so we're not going to use any glass for the top. So this is only the bottom. So that would be, the base would be length times length plus, and then the side walls, there's 4 of them. They're all equal, 4 of them, and that would be length times height. Okay, like, you know, if we're looking at this piece, like over here on the side, like that piece would have the same area as the front, right, and back piece. They're all the same. It doesn't look like it in my picture because I can't draw, but that's what it would be. Very similar to the last one, I'm going to solve this for h and plug it in here. You could solve for L and L squared, just like I said with R and R squared in the last one, but it's much simpler to just solve this for h. So h is 500 divided by L squared, and we're going to plug that in there to solve our surface area. So L squared plus 4L times h, we will replace that with 500 divided by L squared. And again, just like in the last one, we can cancel out one of these lengths with one of the ones on the denominator. And we're left with the surface area equals L squared plus, now this is going to be 20 or 2000, 2000, whatever, however you want to look at it, over L. Okay? So again, there's all your work leading up to the actual calculus part. This is all just geometry stuff, working with formulas. So calculus, again, only plays a small role in this, and that is the derivative, and then the concept of taking the derivative and setting it equal to 0. But other than that, it's mostly geometry and algebra. So the derivative of L squared is 2L. Again, minus the derivative of this is going to be 2,000 divided by L squared. For the same reason as we did before, if we write this as 2,000 L to the negative 1, we bring the negative 1 out front, which makes it a negative. Subtract 1, which would make it L to the negative 2. And if we move it down, we get that. So again, same explanation as what I had said before, but we can repeat it. All right, now let's set that equal to 0. So 2L minus 2,000 over L squared equals 0. So 2L equals, this is basically the same type of math that we just did in that last one. So we're just going to keep going with this here. So 2L to the third, multiply both sides by L squared, divide by 2, L cubed equals 1,000, which means the length is 10 something feet. Okay, so if the length is 10 feet, okay, this is 10, this is 10. You can either plug that in here to get 500 divided by L squared would be 100. So then we know the height is 5. So those are the dimensions of that rectangle, or it's rectangular prism. 10 by 10 by 5. 10 feet by 10 feet by 5 feet, however. Something like that. Okay? So that's what we would have for that one. All right, now let's go on to the last worksheet that I sent you on Thursday and Friday. I'm going to go over numbers 1 and 2, and then we'll just let it at that. So yeah, let's go through this one here. So number 1. Now I looked at their answer key after I did mine, and I did mine a little differently, and I still got the same thing, but I kind of found how many additional passengers would be needed, and they kind of went about it a different way, and their formula looks a little funny. So this is what I did. I said the profit is going to be equal to, first of all, they know that 40 passengers paid $8 each. So 40 passengers paid $8 each. But then we're going to add to that, each passenger after that is 10 cents less. So $7.90 for each additional passenger. And then that's going to be times the number of passengers. Okay, because we have to pay that fee per passenger. Now, this formula A, the additional passengers, we have to find a way of figuring out, well, how many people will we have above our 40? So the way that we do that, like let's say, for example, if there's 58 passengers, then we would have 18 additional passengers, right? So we have to take however many passengers we have and subtract 40 from that, which I did see that in their formula, but the other stuff I had a little bit different from them. So so this is going to say it's $7.90 for each additional passenger. So that'll be like, if I use the 58 passengers, so that would be times 18. So that would we would find out how much we would get for those each additional passengers, but then we would have to multiply that by the 58 total passengers. So, and again, like I said, this was a little bit different than the way that they did it, but I've still got the same result. So x minus 40 and then times x. So we end up 320 plus, so $7.90 times x gives us $7.90 x squared, minus, and then 790 times 40 gives you 316, and then times that x outside there. All right, so now I took the derivative, 370 is gone. $7.90 times 2 would give you $15.80 times x minus 316. So again, this is all in relationship to the additional passengers, the way that I wrote it. So if we do this, 1580 x minus 316, oops, that's not a 6. 316 equals 0. 1580x equals 316. And then when you divide that over, you end up getting 20. Okay, so this is 20. Now, again, the way that I wrote it was additional passengers. Additional passengers. Okay, I don't know if that's how you spell passengers. That might be an A. I don't know. It doesn't matter. So 20 additional passengers, which means the total would be 60. And this problem and number 7, this worksheet is actually the first time I've ever seen these type of problems. But I feel like there's missing information from this. So first of all, 40 passengers hire a special car on a train. There has to be some kind of max there, first of all. So like if, let's say the cars only hold 100 passengers, that would still have to be coming into play here. But then also each additional passenger is still getting them more profit. So this would be the kind where I would say there should be some kind of, we start with no passengers or 40. Actually, yeah, we should start with 40 and not no passengers because we know our minimum would be 40. But then there should be some maximum amount that we would have to try like in a table to see like, would that maximum amount occur at the end point or would it occur somewhere in the middle? Because they're not really losing money. They're still getting money for each passenger. So number 1 and also number 7, not a huge fan of those type of problems. And like I said, I've never seen them until I found this worksheet. And I really don't like their explanation for it. But, I feel like even you would have to know the max here. This would be a type where you would need to know what the end, how many total passengers would fit in this. So anyway, that's a little side note. Not a huge fan of this problem. I wouldn't expect to see that on any AP test, and I can tell you right now, I do not have one like that on my test. So, but it's a good problem to go over and talk about. So number 2, on the other hand, this is one where it's kind of, I did look at this as having an interval, say like, first of all, after 0 weeks, and then up till, we could do this up to 25 weeks, because after the 25 weeks, you can see we're going to be subtracting 1 penny per week. So if we're starting out at 25 cents, after 25 weeks, they're no longer profitable because then you're not getting anything. It's going to be $0 per pound. So this one really does have endpoints. They're not really given to you, but it's something to think about. So at 0 weeks, if they just harvest right now 100 pounds, 25 cents a pound, the beginning of this profit, if we just look at 0 weeks, would be the 100 pounds times 25 cents per pound. Okay, so they would get $25. If they just harvested it right now, they harvest all this fruit, oranges, whatever it is, they're going to get $25. So when we do this, we want to keep that in mind, because if the number that we get for our profit is less than that, then it would benefit us to just harvest it right now and then not worry about it. Now, after 25 weeks, this is going to be 100, 10 pounds, so it's going to go up 250 pounds, so it's going to be 350 pounds, but the amount that you're multiplying by will then be 0, because we're subtracting 1 cent per week. So they're not getting anything for it after that amount. But if we look right before that, like the week before, and it was 240, like $240 times the 1 penny or whatever that would be left, because you're subtracting 24 weeks, so you're still getting, started writing a 24. So it's going to be 24 cents less, so they're still going to get a penny for that. This is going to end up giving us $2.40. So obviously, if we wait until the end of the season, we're not getting hardly anything for it. So we got to find out somewhere in the middle here between 0 weeks and 24 weeks. I guess maybe that should be our end point over here is 24. There's going to be a number that is greater than that. So let's see what we're looking for here. So our profit formula, we're starting with 100 pounds. Every week, this amount is increasing by 10 pounds. So plus 10, we need a variable. I use W for weeks, the number of weeks. So it's going to be increasing by 10 pounds per week. And then we look at the amount we're getting, which is 25 cents. And we're subtracting from this, like I said, 1 penny. Oops, I almost wrote 10 cents. 1 penny per week. Okay? So again, your profit is going to be your pounds times your price per pound. Right? That's what your profit is. Pounds times your price. That's supposed to be a dollar sign. Your price per pounds. Okay, that's how you figure out how much money you're actually making here. So our pounds, going off this formula, is starting out with 100 pounds. It's increasing 10 pounds per week. And then we have 25 cents is what we're starting with. That's the amount we get initially. And then each week it's fewer and fewer, 1 penny per week. So our profit here, multiply all this out, 100 times 25 cents is just 25, minus 100 times 0.01 W is just 1 W, so W. 10 W times 0.25 will be plus 2.5 W, and then minus 10 W times 0.01 W will give us 0.1 W squared. Okay, you can combine these together now or take the derivative and then do it. I just did the derivative and had negative 1 plus 2.5 minus 0.02, sorry, an extra 0 in there, 0.2 W. Set it equal to 0, and this is when I added them together. I said 1.5 minus 0.2 W is equal to 0. Add that over. Divide W. If you take 1.5 divided by 0.2, 15 divided by 2, same thing. You get 7.5 weeks. Now, we're not really given any information in this problem as to whether or not they can, like harvest this at a half a week. So we would have to maybe look at like after 7 weeks or 8 weeks, what would be the profit. So let's see what happens after 7 weeks, because the maximum profit, if let's just say, for example, we can do this in partial weeks, 7.5 weeks would be your answer. So if we come back up here to our profit, whichever one of these formulas you want to use, doesn't really matter. If you come back up, I use this one here. If we plug it into this profit, 100 plus 10 times 7.5 would be 100 plus 75 would be 175 times, and then 25 cents minus, if you take 0.01 W times 7.5, you get 0.075. Subtract that from your 25 cents, and I ended up getting 0.175. So they're 175 pounds, and they're getting 17.5 cents for it. And again, like I said, they don't really say anything in the problem. The way the problem seems is that you can do this every week. So at 7 weeks or at 8 weeks, but we're just going to assume that this can happen at a half week for now. So this total amount would be $30.625, which obviously if we're dealing with money, we're just going to round that to 63 cents. Okay, but like I said, the way that this is written, I would think we would have to look at either 7 weeks or 8 weeks. So if we look at 7 weeks, that's going to be 170 times, and then that really, it should just get rid of this 5 here. Let me just double check. 0.25 minus 0.01 times 7 weeks would be, well, 0.18. Sorry, it's going the other way. 0.18. Multiply that by 170, and that would just be $30.60. Okay? And if we look the other way, if we go out 8 weeks, so that would be 180 pounds, and then times, we're going to do 0.25 minus 0.01 times 8, and you get the same amount. So 7 weeks or 8 weeks, you're getting $30.60 for both of those. Oops, sorry, this would be 80. And then what, I don't know what I got there, minus 0.08, 17 cents. But those are both the same thing, okay? They both give you this number. So if you are allowed to do this in the middle of the week, 7.5 weeks would get you that extra 3 cents. If not, I would say probably 7 weeks or 8 weeks would be your better option, because, you know, like I said, it only says over a number of weeks. It doesn't really take into consideration the half weeks or anything like that. So, and anyway, it's only 3 cents. So I would say, personally, I would say 7 weeks, because then you can start planning more for the next time and, you know, getting more. So anyway, there's number 2 from that same worksheet from number 1. So again, I'm just going to come back here. These are the topics that you will have on your test. So again, just make sure that you understand each of those, what they mean, especially the Rolle's theorem and means value theorem. You know, Rolle's theorem is just a specific form of mean value theorem. But there, you know, just make sure that you understand all of these things and what you need to know in order to find them. And if you have any other questions, just send me an email or something later on today, and I can address each of those. But just wanted to go over a couple more of these optimization problems here today that you had asked about. So let me know if you have any other questions then.